Everyone, I'm Lauren Tan. I guess not many people know my last name. I am Potato on Twitter. Potato with spelled with an E. And I have been at Cursor for about 5 months. Previously, I was at Meta where I worked on the React team, specifically working on the React compiler, which was a whole lot of fun. I'm still on the core team and contributing to open source here and there. So that's really nice that they still let me do that. And before Meta, I was at Netflix, where I was both a tech lead and I transitioned to be an engineering manager for about 2 years. So I've had a lot of experience going between engineering management and being an individual contributor. And I think something I've noticed actually, which is quite interesting, is that there are so many parallels with, management skills and how to like manage agents. And that's actually a big part about what I wanted to chat with you and everybody else about today. But yeah, that's me. I do have some like very light slides, but it's not going to be just rambling. So let me just share my screen and hope that I don't leak anything. Uh, oh no, I need to allow permissions.
No
Sorry.
worries. All
There's
good.
a
Take your time.
there's always tech trouble. Give
Yep.
me 1 second to rejoin.
Yeah, go for it. I see many of you already know Lauren from the looks of the chat here. So yeah, it's exciting to get a chance to chat with her and go through some of her recent work. As you guys heard, a lot of recent experience from Netflix to Meta and then now over at Cursor. We're going to chat a little bit about Grokbot as well. So that'll be exciting. I don't know if you guys saw that was a recent release. I think literally maybe yesterday or the day before from the Cursor team, which is kind of like let's call it like agents for everyone. You can go check it out if you want and learn a little bit more about the product. But yeah, we'll explore that a little bit today as well. Alrighty, welcome back. And Lauren, you're just on mute there if you want to hop off of mute if you're chatting.
Yeah, sorry.
No worries.
It's 2026 and I still don't know how to use Zoom. How am I
That's all good.
supposed okay, so I assume you can see my screen.
Yes, yeah, we're good.
Um, so yeah, today, yeah, I think the big theme for me as I've been using agents to write code, and I'm sure a lot of you have had the same experience as well, is how do you trust it? Especially if you are an engineer that's been writing code for a very long time, you have a lot of opinions and lessons that you've learned about doing good engineering. And when you see agents just, winging it and, guessing, hallucinating, confidently stating that they found the smoking gun for the 100th time, but it's actually not the real problem, you lose a lot of trust. And when you don't have much trust in your agents, I feel like you really can't get the most out of them. And for me, the parallel is like with management. So if I'm a manager, an engineering manager of a team, and I have a bunch of, I have a team of engineers on my team, and I don't trust them, then the mode of operation I'm going to be in is going to be like micromanagement, right? I'll have to spend a lot of time looking over my reports' shoulders and checking that they're doing their work well, that they're not shipping bugs to production. And so I drew this chart because it's not a very scientific chart, but like this is how I imagine myself and my journey through using agents. So, like fast forward or back forward, uh, or fast back, fast backwards, like a year or so, when, nobody was, or not many people were using agents to code. I think you get into this mode where you are in very heavily in the loop with one or several, like a handful of agents, and you find yourself just constantly trying to understand what your agents are doing, and you're very, very in the loop. You're watching every single output. You are sitting there prompting, and you really can't parallelize beyond that because you don't have that trust, right? You can't go to 100 agents, like spawn 100 agents when you don't even trust the output of one agent. So over the past 5 months, I feel like I've really been able to like ascend this trust curve. And now I'm at the point where I actually have this sounds kind of scary to say this, and it makes me sound like a slop artist, but I promise I'm not. But I actually have my agents now auto merging PRs for me, which is like a wild thing to say. But like I woke up today and there were like 20 PRs landed, and I just reviewed them on main, like they were already landed, and they were good. So how did I get to that point? It's basically what I wanted to talk about today. And again, like yeah, feel free to jump in if you have questions, Colin. Um, but oh yeah, of course I gotta show this chart, where uh no, do not trust to re someone requested to control my computer. Probably won't do that. But yeah, so this chart, I think I'm sharing this chart not to kind of like flex, but to kind of show like the journey. Like so you can see like the curve, like it sort of like inversely matches the contributions I've been able to land at Cursor. So I joined 5 months ago, and 5 months ago, like my first month, I was like not very productive because I was learning the code base, didn't know what the heck was going on. And as I got more confident in my agents, I've really been able to kind of ramp up my productivity. And again, like yeah, like last month I shipped 1,000 PRs, which is ridiculous. And then this month we're only on the 12th. I'm already at like almost 800 PRs landed. So the velocity is definitely high, and I'm sure a lot of you will definitely be questioning like how much of this code is actually good. And I think yeah, like that's definitely fair to question. But yeah, I think if you set up your agents well, you can definitely get to a very similar level. And so I'm going to talk about how we do that. Uh, so for me, I think I'm curious, like I guess Colin, your experience as well, but for me, I think the most important skill that you should have in your toolbox when you work with agents is verification. And by verification, I mean the ability for an agent to actually run the code, or take CPU traces or heap snapshots or open an iOS simulator, whatever, however your application is exposed to your users, it can do the same thing and run it for real and actually test and verify its own work. Because that's the thing that really closes the loop. It doesn't guarantee your agent writes good code, but it allows them to at least write correct code, which is a really big step forward for being able to trust your agent. Um, I can share one example that we have within Cursor. Uh, oops, where let me open this. Let me just make this bigger. Make me full screen. There you go. So for Cursor's agent window, so this is actually an interesting story. But when I joined Cursor 5 months ago, they're actually well, I was supposed to join a different team. I was supposed to join like the cloud agents team. But then since I have a lot of experience working on React, and agents window is a React application, uh, I was uh, I was asked to basically help out with the agent window work. But um, there wasn't really a lot of like skills to help me. So I just found myself like, okay, Agents Window is gonna launch in like a week, right? We have a really tight deadline, and there was I was just sitting there like, okay, I'm gonna open up the Chrome Dev Tools and just like take a trace, look at it myself and try to make sense of this flame graph. And keep in mind, I was just like in my first week, so I had no idea what I was looking at, no idea what, I mean, I had some idea, but the code base was completely fresh to me. And I realized like my agent had no idea either. Like I would take a screenshot of the tray, I would download trace, I would send it to it, and it'd be like, yeah, it kind of looks like this. And it would like confidently state like it's this thing, and then I'd try to fix that, and turns out that's not the actual thing. So this was a very, very slow process. And if you've ever done any like performance work yourself, or just even development with an agent where you don't have a verification skill, you are the verifier, right? You're the bottleneck. You tell your agent to do something, and then it goes off and writes some code. Then you open up your local dev build, and then you start to say, oh, it doesn't work. Then you got to copy paste screenshots or console errors or whatever, and then your agent like slowly kind of like works with that, and then tries to understand it and fix the thing. But then you're constantly just in the loop and being a bottleneck. So there's really no way to parallelize. So the control glass skills are like one of the first skills I built for Cursor. And Glass, by the way, is the code name for agents window that we use internally, but it's just Cursor, I guess. And so this skill is, I guess the code itself is not super interesting. Your agent can very easily make one for you. Where if you're building an Electron app or a web app or even iOS applications, you can teach your agent how to use like the Chrome DevTools protocol, or through Apple has some utilities as well for running the simulator and taking traces and controlling programmatic control as well. So that's really useful. But one thing actually want to talk about is the this thing. Where is the README? So this skill comes with this very unique feature called, or not feature, a unique file called a feature map. And so the story then is like I built this skill, and so now the agent was able to actually run the agent window and take traces and whatnot. But it had no idea what the agent's window was. So, um, like someone would say like, oh, the left sidebar is like laggy or something like that, or the right side, the PR tab is not working, and the agent would just be like kind of flailing around. It would spend a lot of time trying to like look up the code and where is this feature? How do I actually get to it on the UI? Which made it basically completely useless. Like I would run this skill locally, and it would spawn a dev build, but then it just be churning. Like I just try to click here, it wouldn't know how to get to things, and it was just an awful experience. So who is putting arrows on my screen? Um, so yeah, this feature map has been really useful, because it teaches the agent how to get to all of the features that you have. And in pstack, the plugin that I've made, if you search for pstack cursor on Google, you'll find it. But there is a create verification skill in that plugin where it actually helps you set up something like this for yourself, including the feature map. So it will actually explore the code and build up this initial feature map that tells your agent how to get to all of the different features that you have. And this is extremely powerful because now like you have these user reports that come in, you can actually map even like a vague report or even a screenshot. So we have this internally at Cursor where we have a Slack channel with lots of people giving us feedback on the agents window and Rockbot and whatnot. And oftentimes the report is very bad, like very low quality. Like someone will just put very often we get like a screenshot, like, and then someone just says question mark, question mark, question mark, like, what is this? And like without this, your agent is like, I have no clue, right? But with a feature map like this, it has a lot more context and understanding of how to actually navigate, how to get to all of the different features. So like, example, like I guess like the sidebar, like what is the sidebar? Like all the different sub features that are present in it. Like from the user point of view, here's how to get to it, all the different keyboard shortcuts, even like the what do you call it, the DOM elements, or yeah, like the attributes that you use for selecting things through the CDP are all there. So again, yeah, this is like really, really powerful for agents.
And
And then pstack ships that create verification skill, but also a maintain verification skill. So you can keep this up to date.
cool. Yeah, I was just gonna ask how you created that. So do you mind sharing a little bit more about that process in the context of pstack and maybe just what pstack is for the folks who aren't familiar?
Yeah, so pstack is pretty interesting because well, first of all, the name is kind of goofy. Like the P in pstack is like potato stack. Because there is a pretty famous person, Gary Tan, who is the CEO of Y Combinator, and he's come up with this plugin called GStack, Gary Stack, and funnily enough, we share the last name. We have no relation, but I thought it'd be funny to kind of poke fun at Gary and make P-Stack my version of of his plugin, but kind of just tailor it to my own set of engineering practices. But I honestly actually never set out to build PSAC. It just started with a bunch of skills, right? Like I started with that control glass skill, and then I started with another skill like called how, which I also noticed through like observing agents. So like, in the early days of me, trying to climb this ladder, I was like super in the loop, and I was basically nitpicking my agents to an extreme degree. I was like, I would tell it, um, this feature has stopped working. Here's a bug report. Like, why isn't it working? And very often, the agent would just like confidently state like, oh, it has to be this, right? It has to be this thing. And I noticed like when I looked at the actual tool calls, I noticed it wasn't actually reading the code that I thought should be affected. And that made me just extremely suspicious. And at that point, I was just like, I can't trust this agent anymore because it's just completely hallucinating. And I think it's very easy to just, like build up that distrust and not and kind of feel helpless, like, you don't know how to help your agents succeed. But like again, I think the management analogy is super helpful because like imagine if you were a manager of an engineering team and you had an engineer on your team who was a really good coder, no business context whatsoever. They just you just hired them and they onboarded, like 5 seconds ago. Uh, and so how do you actually teach that person to be effective? So how you do that is through a skill. A skill being just, it's just markdown, right? But it encodes a lot of information, instructions, a lot of uh you can really draw out a lot of intelligence from an agent by, well, some people on Twitter call it like, pull the agent to a different latent space, which is kind of like a fancy way of just saying, like, since LLMs are sort of like they predict the next token, when you give it some high quality tokens to begin with, then it can kind of pattern match on like a higher space that's smarter. So that's like a very interesting model there. But yeah, I built pstack very, very incrementally. Started with just really observing how agents, all the different failure modes of that agents were having. And every time I saw that, okay, I'm just gonna make that a skill, right? Like stop hallucinating, actually go and look up the code, use a lot of sub agents, and yeah, stop guessing.
Yeah, that makes sense. One kind of follow-up question here, both from myself and from a bunch of people in the chat. So well, I guess it's two parts. So one is like, how do you maintain these skills? So like the product changes over time. Obviously, there's a lot of people who are shipping against the code base. So how do these skills get maintained? And then second to that is like, how do you know when your verification is good enough? Like in, you can trust that the verification loops that you've built are gonna, I guess you trust the outputs when they're done.
Yeah, maybe I'll talk about I think they're somewhat related. Maybe I'll start with this one first. So like how do I maintain these skills? So if you're not familiar with this concept, an eval is essentially like a way to well I think the mental model I have is like it's like a unit test for an agent. And you can actually make your own evals. You don't need like a special framework for them. You can build one depending on like how scientific and how rigorous you want to be. My screen is red.
Yeah, there's a little button. Sorry
Oh,
for the
and do you
folks.
mind like disabling the drawing or something? I can't see my screen.
Yeah, sorry. If you guys could not draw on the screen, that'd be great. But there's a little button in
I
the
got a troll in
yeah
the audio.
the little drop down.
How do I clear?
Yeah, one
Okay, yeah.
second. You got it. Perfect.
Um,
Continuing.
yeah, so evals are a way to unit test your skills basically. And actually in PStack we ship under potato mode there's a playbook if you search for it called eval playbook. And it's like not it's actually pretty rigorous the way it's done. But essentially what I do is I spawn a lot of different sub-agents. I have like my main coordinator agent come up with a rubric for what I want the skill to do. Um, and then it spawns all these sub-agents and it creates individual directories for them, which are cleverly named to not let the sub-agent know that it's being evaluated because agents can actually tell, and when they do, they change their behavior. But it does a bunch of stuff like that to essentially, yeah, like test whether or not the skill I'm making or changing is actually doing what I think it does. And one of the really nice things about Cursor is that we support so many different models. So you can actually eval your skill across all sorts of different models, and get a sense of how well it performs across that different matrix, especially for the models that you use. So I do this a lot. Every time I modify a skill, I will run one of these, like the eval playbook, and make sure that it's actually leading to a result I want. But I will say like maintaining skills is actually pretty hard. It requires, I think, a lot of taste and observation. So you kind of need to be very good at being a backseat driver. You know what I mean? Like if you've ever done pair programming, for example, and you watch a coworker code and you just like you could probably do this better. Or, you could do you're like why did you not do this, right? You ask a lot of questions to your coworker, and it's kind of a similar thing here. You don't want to just be a passive observer of the agent. You want to be very in the driver's seat in the initial stages when you're building up your own set of skills. Obviously you can use something like PSAC, but if you're building your own set of skills, it's very, I think, opening up all the tool calls and like reading the code and reading all the agent behavior and their thinking blocks is a really great way to see where they fail, right? Like what where are they being dumb, and then you can go and build a skill for that. And then with verification, how you trust it is, I think it's also a very similar iteration loop where like I actually did the same process for verifying the verification skill where I actually get um so one thing that's interesting about evals is that you can sort of hill climb them, meaning that your eval can produce a score, right? A score that you can get your coordinator to produce, but also you can have a judge agent of a different model to kind of cross-reference and make sure that the first model is not being biased, right? The model that's judging all of the subagents that are running the thing. But you can also like hill climb. So meaning that you can use like slash loop in cursor and you can say, okay, keep looping on this eval, right, until everything is 10 out of 10 as an example. And I did basically the same approach with the control skill. And so it was very hands off actually. So I kind of built that skill that way, like the CLI in that skill. And over time it's gotten really good. But yeah, it was definitely not super smooth at the beginning. It required a lot of iteration. And I think there's an analogy here for me, which is well, I make this analogy later in a different slide on my drawing here. But I think of it like as a engineer now, you're sort of more like maybe a manager, or the analogy I like is like you're like a chef in a restaurant. You're the head chef. You're not cooking all the food yourself anymore. You have a team of cooks, right? You have line cooks, you have a sous chef, you have, all these different stations. Um, and it's your job to really design the environment. You're in charge of setting up the kitchen. You're in charge of, like giving tasks to different people. So, um, yeah, it's a very interesting way of working. But yeah, that's how I basically built these verification skills.
Yeah, just one follow-up there on like
Hmm.
to go try to go one layer deeper. So are you, let's say we wanted to build an eval or a skill for something, and we wanted to kind of get better on its own, which is what I think you're suggesting. Are you
Oh, I
doing
see.
that in like a work tree, kind of isolated with like the sub agents and then the reviewer agent and all that? Is it happening like in some type of cloud hosted environment? Like what's the practical steps? If I wanted to go do this and like set up a verification system for something, what would I do or where would I start?
I think that the best place to start is local because you can observe. You can definitely observe what your agents are doing. So, if you're building a verification skill for yourself, I would definitely start local and just have your agent bring up the application, whether it's like a CLI or a desktop app or whatever. And so you can actually observe, right? You can see how the agent is interacting with the application. You can see it, how it calls like the different APIs that allow it to interact with the application. But for me personally, I have basically been kind of mostly all in on cloud agents because they're extremely powerful. Uh, and the really powerful thing about Cursor is the cloud agents actually, where if you spend a little bit of time setting up your environment, these control skills, these verification skills pay a huge amount of dividends because it's not just something that makes you as a single engineer better. It actually levels up your whole team, and even your whole company because you can actually start thinking about cloud agents. You can start thinking about automations that automatically do things like I kind of talk about this a bit later, but I'll just kind of get into it. Where for example, like I talk a lot about this agent we have called Benny, right? Who takes all of the bug reports that we get and it automatically goes off in the cloud, opens up a cloud its desktop. It runs Cursor in its own computer and it uses the same control skills to interact with the application and try to reproduce the bug or the user report, right? And this is so powerful because at once I can immediately I get so much information from this automatically. Like here in this example, you can see that the Benny actually reproduced the bug, but it's already fixed on main. So it actually confirms that we fixed this problem already, and all I need to do is just release another build of Cursor. So that's like huge information there that I didn't have to go off and sit with an agent, and spend an hour trying to figure like, is this fixed? Is this not fixed? So you gain back so much time. But everybody on my team benefits from this. Everybody in the company benefits from this. So definitely think that keeping these using cloud agents is super powerful. But yeah, it's like a journey. You have to trust it first, right? Before you get to this point. And it goes back to what I was saying here, where it's very hard. It's almost impossible, and I would definitely encourage you not to try to jump from, like if you're still in this zone, you don't want to jump to like I'm gonna spawn 100 of thousand or thousands of cloud agents right now, because you're just gonna waste a lot of tokens, and it's gonna be extremely expensive.
Yeah, so just to kind of recap so far, basically the if we wanted to go on the journey that you've kind of gone on, it would be just start with verification, building some skills and some ways of determining that the agents are producing at least
Yeah,
like correct code, whether like you said, whether it's good code or not is maybe a separate question, but like it's technically solving the problem by looking at, stack traces, looking at, the actual behavior in the app and so on. And then once we trust it locally, then we can start to think about scaling into the cloud and running more agents that are picking up signals, I guess, on their own, right? So whether that's like a bug report that comes in or something, they can go and pick it up and solve the problem and give us back a PR. And then maybe the last step is like auto merging the PRs, which is where you're at
yeah,
and maybe not where everyone is
yeah,
at.
yeah.
And then reviewing them on main. But is that about right?
Yeah, exactly. I think yeah, that's why I drew this curve, right? Because this basically describes my journey of, when I started, barely could use a couple agents and I was just observing every single thing. I think there's really no shortcut for going from here to there because this is really about your personal level of trust in agents, right? Obviously, as an engineer, you don't want to just slop code into production. So how do you actually build up that trust? Takes a lot of I guess taste and judgment. But like I think plugins like pstack definitely kind of help you get up to speed much quicker. Uh, and so I guess it's like if you trust me and you trust pstack, then in by extension you can maybe trust your agents. But if you don't trust me, and I definitely would not encourage people to blindly trust me, uh if you build up your own set of skills that you can obviously, take a look at PSEC and kind of fork it, make it your own, improve the skills, definitely encourage that. But for me, yeah, it's really all about it just keeps coming back to trust. Every one of us here in this chat have a different standard for engineering. And there are different things that are important for us in our code base. And when you are able to encode all of that into skills and you can verify that your agent is actually doing them, that allows you to really kind of ascend this curve and start automating things. There's another piece I wanted to talk about. If there's no more
Yeah,
questions
go for it.
on
I'll pick
agents,
up
I
more
think
questions as I go, but yeah,
yeah, I think there's
keep
a
keep.
third part to this which I haven't talked about yet, which is kind of an interesting one, which is like refactoring and rewriting. Like I guess one of the most controversial topics in the industry, I think, is like, should you rewrite your app or not? Because I think engineers are very prone to this, where especially when you join a company, you come in and you see like the code base and you're like, oh man, this is shit. Like who wrote this code? It's terrible. I want to rewrite the whole thing. It's a very common inclination, and I think a lot of, before agents, and I guess arguably even now, people will definitely discourage you from rewriting stuff. But I'm actually here to make a case for why you might want to consider it. Because I think it really depends. Brownfield applications I think are actually in a pretty good spot, especially if they're set up well already. And like recently I've been talking to some people, but I was just observing, I just noticed this parallel, which is that a lot of big tech company problems are now everybody's problems. And the big tech company problem, like when I was working at Meta, like we had this giant monorepo. We had like, I don't know, tens of thousands of engineers just, like banging on their keyboards and shipping code. And a lot of really great engineers at Meta. But I'll say like, you'll be surprised that the code quality is actually not that good. And so I often joke that like, before AI slop, we had human slop. Um, and so I think a lot of big tech infra, like what Meta has or Google, really big tech companies are actually designed for that, where you're sort of like you're catering to the like this sounds so bad to say, but like the least capable engineer on your team, right? You build frameworks, you build conventions, you build guardrails, you restrict credentials so that your intern doesn't wipe your production database. Um, there's if you have that level of infra already, I think your agents can actually already do a very solid job, right? Because they have the guardrails are already in place for agents to not cause havoc, or not cause too much havoc in your code base. And you can always add more, guardrails. But I think like greenfield applications, especially are, like the brand new applications are like the biggest risk, in my opinion, and also the greatest opportunity. Because, if you vibe code a project, a prototype, like we did for Grokbot, Grokbot was spun up very, very, very quickly. And if you haven't heard of Grokbot, it's like a new application we just launched yesterday. It's really cool. Lets you orchestrate your create like individual agents that have their own identity, and you can kind of orchestrate them. It's super cool. Definitely check it out. But yeah, it was a very greenfield application, like most prototypes are. So it was like vibe coded very quickly. Humans were not reading the code at all. And I had this tweet recently where I said something about organic architecture. Um, Maybe I'll find it. But the idea is that when you have a completely vibe coded application, you essentially have no guardrails whatsoever. So your agents, when you give them a task, they will just solve it in whatever method is the most convenient. And over time, you get into this situation where you have a code base that is spiraling out of control because you don't understand it. Your agents understand it, I guess, in a way, but like they've built something that is, optimized for shortcuts. And you will suffer, you'll have a lot of issues with that application. So I think starting your code base with like very strong constraints is very much needed. Because like when you have a code base that you can trust, right? When you have guardrails that actually uh help your agents write good code, you can get into like into this part of the curve where I said, I woke up today and I had like 20 PRs merged by my agents. And that's because I invested a lot of time, over 600 PRs. I calculated yesterday, when I refactored all of Grokbot to this new architecture that I've been building. Um, and yeah, I've gotten to a point where I really don't look at the code anymore. And I say that not just, to sell you tokens, but because it took a lot of work to get to that point. I spent a lot of tokens to get the code base to this point where I no longer have to look at it. But I'm very excited because, of the potential where, this doesn't just benefit me, it benefits everyone contributing to Grokbot, and it also empowers designers and product managers and people, even GTM people to add features to Grokbot. And I don't have to worry, I don't have to wake up at night in the middle of the night and worry like, oh shit, someone's just merged a perf regression, right? I have a ton of constraints, and CI is like, it's actually very annoying to write code in in Grokbot, but like agents absorb all of that annoyance. But yeah, I'm happy to talk about what exactly that is.
Yeah, I think one question
Yeah,
before we get into the this part here is just around that element of like what your CI looks like, or maybe some of the constraints, and then also like the average PR size. I saw a question about that earlier. Just to give people kind of a glance. It doesn't have to be like mathematically average, but just like what
yeah.
generally the size of the a PR is. If it's only a couple lines of code or yeah.
Uh, um, I think it depends. I'm trying to do this in a way where I'm not gonna like
Yeah, you don't have to share the actual number if you like the actual average,
I think
just
this is fine,
benchmark.
but like we have so okay. This is not that interesting, but well, fun fact is that virtualization in Grokbot and in Cursor is actually powered by Pretext, which is a sort of new library that someone's built. That's really interesting. You should check it out. But that's not really that important. I think the average PR size, I actually don't know. I don't know if I want to click on these. I probably can, but I would say like they can range anywhere from a few hundred lines or 50 lines to like 1,000, depending on what the thing is doing. So like here I'm actually like deleting a bunch of files, so I expect that it's just as like mostly deletion. But yeah, it kind of varies. There's
Got
no
it.
like, yeah,
There's no like hard cap or hard limit, or they're all like 50 line
there's no hard
PRs.
cap. Yeah, there's definitely no hard cap, but I do encourage my agents to split up their work into multiple PRs. I do that mostly because I like I like the idea of the I guess maybe this is much harder to do now as in the world of agents and you have like so many commits. But I like the idea that, the Git history is a very rich source of context. And I like each PR to sort of atomically describe what that small piece of thing is doing, which also makes it easier for me to revert changes and like figure out, oh, I shipped a bug and it's here, right? It's not in this 40,000 line PR where who knows what landed in there. But yeah, I don't have a hard cap on PR size.
Cool. And then yeah, also quick question on like CI. So again, you don't have to go into like the screen share of like your CI does, but just
Yeah.
generally, would you describe what the CI kind of looks like or how strict it is?
Yeah, so well, specifically for Grokbot, so Dune is the sort of cheeky code name for the architecture that we've built for Grokbot. The CI looks pretty annoying because there's checks for everything. So like literally I have well, if you've written any React, for example, you know that one of the biggest foot guns in React is use effect. So in Dune and in Grokbot, we've banned use effect. So Dune is just the mental model of what Dune is. You can kind of think of it as like Next.js for Electron apps, and it's designed for agents to write. And it's like custom for our agent powered applications. Um, so the CI checks are very like specific to that. Like, don't use effect. It's banned. Like CI will fail, and yell at you. We have like some of the more interesting ones that people might raise eyebrows is like I actually ban code comments as well, which is very interesting. But I've noticed that 99% of the time, agents just write code comments that kind of describe some historical thing that is actually totally irrelevant to the code. Um, like it will often say like, oh, Lauren said you should never do this, and it's now in a code comment. I'm like, what? Like, why? What? That was. I didn't say that as like a durable, global rule. I just meant like your this PR sucks, and you should change that part. Agents don't really understand this that well, surprisingly. And or they kind of assume too much and they kind of do things in like very stupid ways. So like yeah, we just ban everything. Everything you can imagine like the agents are bad at, we ban. So one example that we actually suffer a lot in the agents window is we have if you've used the agents window, you've definitely seen performance issues and we're constantly trying to fix them. But it's a never-ending struggle because there's so many pull requests that get merged. Any one of them could just regress performance or stability or reliability. The agents window doesn't have this architecture yet. I plan to bring this learning back there and kind of refactor everything there. But it just regresses super often. Because there's just one example is like we have very poor isolation between processes. So like on Electron, you have a renderer thread that renders your UI, but you also have like a main thread that you can run other code that doesn't need to block the renderer. But we do a poor job of separating those things, and so oftentimes you just accidentally have code that gets pulled into running on the renderer thread, right? And then all of a sudden you're competing with the renderer that has a very if you want like 60 FPS, you have to every frame that gets drawn has to be done in 16 milliseconds. So very, very small, deadline per frame. If you want, a very smooth product. And when you start accidentally bringing in, things that are like very computationally heavy or they have a lot of I/O, then you just get into like a lot of jank. Right? Your FPS really drops. You start, losing frames. You get long tasks that take more than 16 milliseconds, and you just get this really choppy experience. So all of those patterns that we've learned basically building Electron apps, we've encoded into this framework and it becomes like a hard failure. So I literally in Grokbot, we literally have a directory called Electron main, Electron renderer, and we have import CI, I guess, where we actually check the dependency graph to make sure you're not accidentally importing code from one directory to another. So that's enforced by CI, as well as BugBot, which cursors like code review tool that runs on CI. In our agents MD, it's everywhere. Like so, I I have this thing here where I talk about like like there are multiple layers I think for building a good code base. Obviously, the code base is one where if you have an architecture like this, where it's extremely strict, the way to build features is very conventional. That's like the strongest level of enforcement because agents just love to copy existing patterns. So, one example of this in Grokbot is like we have these concepts called like a feature, and we have entry points and transcript cards, like the cards that you see in the chat. These are all like nouns, I guess, in the framework, and so there's a very conventional way of creating them. And so like a feature is all in a single directory as an example. And so all of the code that contributes to that feature lives in one directory. So it's all co-located in one place. Makes it super easy. Agents don't have to like grep around and try to figure out like where all the things are. It just looks at the feature and like, oh, okay, I'm working on the onboarding feature in Grokbot. I'm just gonna work in this directory. And for 80% of the work, it's mostly just very encapsulated there. But like it's like designed again for like the dumbest agent. Like you don't have to think, right? The one of the key principles I have for this framework is like the shortest path is the best path. So, because that plays exactly to how agents love to write code. It's like they like to take shortcuts, really. They'll find the quickest way to solve the problem. So why not make that the best way to solve the problem? So I probably won't get into all the specific details. And this framework's really more of a collection of ideas and principles rather than something that will open source. You can screenshot this, I guess, if you want, and tell your agent to build something like this for you too. Um, yeah, but it's really all about the layers. Like the code base is one part with features, and directories and import blocking import dependencies that shouldn't be imported. But and it all enforces that and static analysis. So like there's CI checks. We have a lot of lints for bad patterns that we observe. Compiler diagnostics. There's also rules and bugbot, which are I think like 3, 4, 5 are more soft, right? These two actually make make CI red, right? So that there's a hard constraint where the agent can't just write crappy code. For rules and skills and bugbot, your agents can still forget, right? You can still, or it may not always consistently apply them. So I like to layer them, but I don't like to rely on them as the only source of enforcement because it's very, very soft, right? And if you only have rules and bugbot and skills and a style guide for your code, you will it's only a matter of time before your code base looks like complete trash. Sorry to say that, but I definitely recommend, yeah, like investing in things that can be hard enforced, right? And this is why maybe the choice of tech stack that you use is also very important. Um, like I think, for example, Rust is sort of making, it's like getting super popular again, because the compiler is so strict, right? The compiler enforces so many different things. There's a borrow checker that you have to appease, and as long as you make sure your agents don't write unsafe code blocks, you can more or less feel somewhat confident that if the code compiles, it probably works and it's good. But you see, it gives you that level of trust and confidence that you, as a human engineer, no longer need to go and check it yourself. You rely on code and static analysis to actually make that a lot smoother. And I guess the worst place to be in is if you are stuck in code review land, where you actually enforce all of the constraints, the invariants in your code base by literally the human person saying, reading the code and be like, okay, you should not do this, right? Every time you have to do that, you should consider that as a code smell, like a anti-pattern. And you should say, okay, instead of me commenting on the PR, how do I turn this into a hard rule, right? How do I turn this into a lint rule? How do I turn this into a CI failure? Or how do I even categorically eliminate this problem entirely? Uh, I can talk about another migration I've done, but I'll probably pause here.
Sure.
Uh, yeah,
Yeah, I feel like that's where I am, to be honest, is what you're describing right now, which is that like I don't have all of these rules. So
right.
I have some things to go do after this session. In terms of being able to scale my agents, I'm definitely on like the maybe a couple of parallel ones locally staged, so like 2 to 3 locally. And I'm sure most people here are on the same. So yeah, I know we only have a couple minutes left. Lauren, was there anything else that you wanted to highlight? Obviously there's lots of questions, so I can grab more, but I want to give you a few minutes if there's anything else you want to talk
Well, I think
about.
I've been yapping for quite a lot, so maybe let's just do questions.
Okay, cool. One question that had a couple of came up a couple of times was just around like token usage. So the question is like, is what you're describing a
Oh no.
realistic thing for people who are on, a normal set of token usage? They don't have, basically unlimited tokens to work with.
I think that's a really good point. I mean, like obviously, I work at a AI lab where we have unlimited tokens, so I definitely cannot say that, this is something everyone should do in the exact same way that I did it. I think it's possible to get to this point without, breaking the bank. But if you're like an engineering leader or you have a startup that you lead, I think to me it's a question of ROI. And it's like yes, you spend a lot of money on tokens in the upfront stage. Like refactoring your code base is going to take a lot of tokens. Adding all these things is going to take a bunch of tokens. But if we're heading to a world where agents are writing all the code and you want to be very lean, right? You don't want to have to hire, you don't want to become like Meta, right? Like I mean like in terms of you don't want to become a 10,000 person engineering org because I mean, that's a cool problem to have, but also, you have so much overhead. There's like planning, like it's personally I wouldn't it's not super fun. But I think you want to stay very nimble, right? And you want to be like agents are all about allowing you to do things that you couldn't do before. That's really to me like the value of agents. It's not just storing tokens on every single little thing. But to me, like the thing I couldn't do before is like enforce this level of constraints in a code base by myself, right? Like I'm just a single person, it would have taken me years to build this framework, and do all the refactoring and test everything myself and verify, like run. Imagine if it was just me, right? No, in pre-agent era, just like running, it by my. It would take me so long, right? And my salary is pretty high, right? Like so, the question I think an engineering leader might have is just then, like, there's a trade-off of do you hire someone to do this, or do you spend the tokens to set up a code base so that even the most naive, right, the dumbest agents can do a good job. And when you actually get to this point, like even agents that are not, Fable size do an excellent job of writing code. And this pays a lot of dividends as well for me and personally, where I have empowered not just myself, but again, like PMs, designers, engineers who are not familiar with Grokbot to just contribute in a way that is sustainable. So I think yeah, it's definitely like a trade-off for sure. Like nothing is like free for sure. And tokens are pretty expensive. But oh, actually, I don't know how many of you have seen this, but we actually announced Grok 4.6 today. So very exciting, finally out. So yeah, Graph 4.6 would be like a great. It's very, very smart. It's really good on the benchmarks. And it's the same. The tokens. I hopefully I'm not saying this incorrectly, but I believe the cost per token is the same as 4.5. So you're actually getting more intelligence for the same cost. I think this is an area that Cursor and SpaceX AI try to really optimize for, like that Pareto frontier of, cost versus intelligence. We don't necessarily want to build the biggest model ever because that is extremely expensive to run. It's really about like how do you find that sweet spot, right? You don't need a giant model, but it's just super smart, right? And it's not very expensive for inference. But yeah, I think to kind of round it up, I think it's like it's there's a if you do your own analysis, I feel like it's pretty positive. It'll be pretty positive that the ROI you get from investing in stuff like this, just empowers not just yourself but your whole team to be so much more productive, right? Like imagine if you have an army of engineers like me who are shipping so much improvements and bug fixes every day, right? Like that is pretty exciting.
Cool.
Uh,
One last question before we wrap up.
yep.
This one is for the people in product on the call.
Yep.
So let's say we do have an army of engineers who are shipping like Lauren. I'm just
Mhm.
curious, like, how is the product team or other functions of your company keeping up, given that, like, if you're shipping so quickly, are they using AI more to do their jobs? Like, as much as you can speak to that, and obviously you don't have, like, you're not in that role, but just curious about how that works.
I think this is where Grokbot has been actually exceedingly powerful. Where so before Grokbot, like obviously Cursor only had Cursor, like we only had agents window, we had a CLI, we had an IDE, and these are really like power user tools, right? They're designed for developers, so it's very, very developer centric. You can do knowledge work in them, but it like the UI is not really optimized for that. So we actually didn't really have well I think like a lot of people in like GTM product, like they might have used Cursor to do their work, but it definitely wasn't like a delightful experience for them. I think now with Grokbot, it's become Grokbot is basically like the Cursor moment for people who are not in tech, in my opinion. Like it's like a very, very accessible way to use agents in a very comfortable, very familiar interface. It looks like iMessage. And it's very fun too. You can give your agent a fun name. You can kind of do orchestration in a very like natural way where you can sort of each agent's like a person, and now you got a team of agents like working on you have one agent per account that you manage as an example. Or if you're a PM, you can have an agent that summarizes all the work that Lauren did last night, and then now you know what I did, right? So I think our PMs are leveraging that a lot, and they're shipping code too. So like oftentimes they will just say, "Oh, here's a bug. I fixed it. Can you look at it?" And then I'll go review it, and actually, it's just perfect. I'm like, "Okay, stamp." So that I think that shows that the Dune architecture is holding up, right? The all the really strict constraints allow people who are not experts in engineering to contribute at a high level. So I feel like I'm already seeing that pay off a lot, where designers and PMs are just able to ship features directly, and that just makes the Grokbot team super fast, right? Where we can ship so quickly, um, and we have a lot planned, so I'm very excited you know, uh, to ship more, ship more stuff.
Yeah, that's awesome. Well, we are at time, so I guess Lauren, if folks want to support you, maybe go try out Grokbot, try out
Mhm.
4.6, and provide some feedback. But yeah, this was awesome. Really appreciate you taking the time. Thanks everyone for all the messages in the chat. Lots of good questions. I know we didn't get through everything, but as I kind of said at the top, way more questions than we could get through. But yeah,
Yeah.
really thanks for joining. Thanks everyone for joining, and hopefully you enjoyed the session.
Yep.
All
Yeah,
right.
see you. Thanks for having me. And if you have any more questions, yeah, just DM me on Twitter. I'll open them up. I guess I'll let the let the floodgates.
You're gonna get a lot of DMs.
Yeah,
It
I'll,
looks
I'll
like,
open the
but
floodgates. So
yeah.
yeah, DM me. Maybe I'll do like a Twitter space at some point as well for more questions. But really appreciate everyone for showing up, taking an hour out of your day.
Yeah. All right. Thanks all. I'll see you the next one.
Okay,
Thanks.
thanks everyone. Bye.